Hello, ma'am. Hello, everyone. Now we're in lecture number 5, Electromagnetism, and now I'm going to explain the example 11.1. So, problem set number 1, example 11.1, an alpha particle moving in magnetic field. So, in this problem, or the given or the figure 11.5, and the charge, which is 3.2 times 10 raised to negative 19 coulombs, and the magnetic field is equals to 1.5 Tesla, and we're going to find the magnetic force in the positive x direction, speed of 5.0 times 10 raised to 4 meter per second. And B, magnetic force in negative y direction, speed of 5.0 times 10 raised to 4 meter per second. Letter C, magnetic force in positive z direction, speed of 5.0 times 10 raised to 4 meter per second. And letter D, magnetic force, the velocity of 2.0 I vector minus 3.0 j vector plus 1.0 k vector times 10 raised to 4 meter per second. So we are given the charge, its velocity, the magnetic field strength, and direction. We can thus use the equation magnetic field is equals to charge times velocity times magnetic magnetic field, or magnetic force, or force is equals to charge times velocity times um, magnetic field times sin theta to calculate the force. So the direction of the force is determined by RHR1. So letter A. First, to determine the direction, start with your finger pointing to the positive x direction. Sweep your fingers upward in the direction of magnetic field. Your thumb should point in the negative y direction. This should be match the mathematical equation. So to calculate the force, we use the given charge, velocity, and magnetic field. So magnetic force equals to charge times velocity times magnetic field. So charge is equals to 3.2 times 10 raised to negative 19 coulombs times the velocity, which is 5.0 times 10 raised to 4 meter per second I vector times the magnetic field, which is 1.5 Tesla, and k vectors. So the magnetic force is equals to negative 2.4 times 10 raised to negative 14 Newton j vector. So for letter B, first, to determine the directionality, start with your finger point in the negative y direction. Sweep your finger upward in the direction of magnetic field as in the previous problem. Your thumb should be open in the negative x direction. This should match the mathematical answer. To calculate the force, we use the given charge, velocity, and magnetic field. So same process with the previous question. So magnetic force is equals to charge times velocity times the um, magnetic field. So 3.2 times 10 raised to negative 19 coulombs times negative 5.0 times 10 raised to 4 meter per second j vector times 1.5 Tesla k vector. So the magnetic force is equal to negative 2.4 times 10 raised to negative 14 Newton in I vector. Letter C. We use um, we use the alternative approach, is the equation 11.2, to find the magnitude of the force. So this also applies both part of A and B. And since the velocity is perpendicular to the magnetic field, the angle between them is 90 degrees. So therefore, force is equals to charge times velocity times magnetic field times sin theta. So it's equal, substitute the value 3.2 times 10 raised to negative 19 coulombs times the velocity, which is 5.0 times 10 raised to 4 meter per second, times magnetic field, 1.5 Tesla times 90 degrees. So sin 90 degree. So the answer is equals to 2.4 times 10 raised to negative 14 Newton. Now to calculate the force, we use the give for letter D. First, to determine the direction, your fingers could point in any orientation. However, you must shift your finger upward in the direction of the magnetic field. As you rotate your hand, notice that the thumb can point in any x or y direction possible, but not in the z direction. This should be match the mathematical answer. So, to calculate the force, we use the given charge, velocity, and magnetic field. So, same calculation we have on same process. So magnetic force equals to charge times velocity times magnetic field. So substitute the value 3.2 times 10 raised to negative 19 coulombs divided by I times 2.0 I vector minus 3.0 j vector plus 1.0 k vector times 10 raised to 4 meter per second times 1.5 Tesla k vector. So the magnetic force equals to negative 14.4 in I vector minus 9.6 in j vector times 10 raised to 15 Newton. So this solution can be rewritten in terms of magnitude and angle in the xy plane. So the absolute value of the magnetic force is equals to the square root of f sub x squared plus f sub y squared is equals to square root of negative 14.4 squared plus negative 9.6 squared times 10 raised to negative 15 Newton is equals to 1.7 times 10 raised to negative 14 Newton. So theta is equals to 10 raised to negative 1 fy divided by fx is equals to 10 negative 1 times the negative 9.6 times 10 raised to 15 Newton divided by negative 14.4 times 10 raised to negative 15 Newton is equals to 34 degree. The magnitude of can also be calculated using equation 11.2. So the absolute value of the velocity is equals to square root of 2 squared plus 3 squared times 10 raised to 4 meter per second is equals to 3.6 times 10 raised to 4 meter seconds. So the force is equals to charge times velocity times magnetic field times sin theta is equals to 3.2 times 10 raised to negative 19 coulombs times 3.6 times 10 raised to 4 meter per second times 1.5 Tesla times sin 90 degree is equals to 1.7 times 10 raised to negative 14 Newton.